Hi Fan, I'm the PC Expert Amateur, and we're going to do the 23rd episode of the airflow and pressure differential, a comparison of 120 millimeter fans. And this time around, as always, I need to remind you that this is my anemometer, and because it doesn't have enough precision to it, I can't get the airflow numbers to be exactly as they should be. However, they are sufficient for me to rank the fans based on the airflow results. Also, I'm using CMHs, which is cubic meters per hour, instead of CFM for measurements. And these are the fans that we're going to be looking at today. The Sama Ice Lantern 2S SF411, the Frostwind from Foshan Chimai Trading Company Limited, which I call the, well, not really I call, but it is they say it's a silent case fan. I just say it's a QM12CM4XDS00001. Yeah, that's all I could find about it for an actual model number, but I think actually I did find something on here that suggested that this is a publicity item. So I think it's like probably not something that is common and may have been put out to get customers to buy the fan from the actual manufacturer, but I just don't know. The next one is the Vetroo DF120. And then I have the MantisMan double fall spring table PC RGB. It's not actually RGB, it's an LED. And finally, I have the Enermax T.B Vegas Duo. And there's something special I have to tell you about this fan in just a minute. But first, I want to show you the RPMs for each of these fans. So let's go ahead and do that. There it is. All right, so the Sama is the weakest at 1,234.3, which is still within specifications and slightly above the published rate. Vetroo was at supposed to be 1,300 approximately. It came in at 1,244.3. Not surprising, Vetroo does not make amazing fans. The MantisMan was supposed to be coming in at over 1,600. It only came in at 1,420.4. The Frostwind was supposed to come in at least, well, I'm not really sure, because I had very little information about this fan, which I found on Temu. But it turned out that it was 1,740. And then the Enermax T.B Vegas Duo, it was supposed to be 1,700. It came in at 1,879. So what I'd like you to do in just a minute, because I want to show you something else about the Enermax, is tell me which fan you think will have the strongest airflow and which will have the highest pressure differential. So what I need you to understand about this fan is fairly unique. Not only does it have a MolXD adapter like this, which makes me have to do more testing, it also has a potentiometer, which is kind of, it's really a misnomer because it is a dial, or not, you know, it's for adjusting the speed just by turning this thing here. If you can see that. All right. So that meant I had to do several more tests than I had hoped for. Unfortunately, doing those extra tests for the purposes of ranking these fans distorts the power of the Enermax. So I removed the excess information from the results because it was skewing the data for the Enermax a lot. Now, here's what I took out. Some of it's what I took out. So these are test results with the 3-pin and the potentiometer set on minimum and on maximum. So that's why we got min-min and max-min. And then max-min and max-max are when, so min-min and max-min are when I'm doing it at the lowest voltage, and max-min and max-max are at the highest voltage. Okay, so with the MolXT, I can only do maximum because I have no control over how the fan moves with a 2-pin MolXT. So there's only that max min and max max. In other words, this information shows you the full range of possibility using the potentiometer and using the adapter. Probably, and with the MolXT, also with the potentiometer, by the way. So the 3-pin at minimum voltage and with the potentiometer set to minimum, or the pot set to minimum, was 271.5 RPMs. Maximum minimum, where the potentiometer was set at maximum and it was still minimum voltage, was 700 RPMs. Now, when I switched it to maximum voltage, but with the minimum setting on the pot, it was 900. When I maxed it out, it was 1920. When I switched to the MolXT instead, the minimum that I could achieve with the maximum voltage the MolXT provides was 913.7, and the upper end, when I put it up to the maximum voltage on the pot, was 1839.7. Then for airflow, which is measured in CMHs, with a 3-pin set at minimum for the potentiometer, lowest voltage, the minimum I saw was 0. But when I don't know why I put in the 69.6 over there. That's a mistake. Ignore that. But the maximum is with the minimum voltage, but maximum potentiometer speed is 69.6 CMH. And when I put it on maximum voltage with the pot set to minimum, it was 93. And when I maxed it out, it went to 180. The MolXT with maximum voltage and the pot set to minimum was 91.8. When I put it to maximum, it was 181.2. And then for the pressure differential, when I had the voltage at minimum and the pot at minimum, the degrees, 34. When I maxed out the pot, it was 67. When I put the voltage up to maximum and the pot at minimum was 38. Maximum for both was 70. When I did the same thing with the MolXT for the maximums, I got the same results. So that is not all in the chart because it screws up the numbers and makes the Enermax look much weaker than it really is. If you have any questions about that, put it down below and I'll see if I can clear it up for you. And I hope you put your guesses about the best ones for airflow and for pressure differential in the comments below. So here's the big reveal. So the Sama, unsurprisingly for me anyways, it was at 118.8, as was the MantisMan. The Vetroo was at 133.2, Frostwind at 159, and the Enermax 180.6. Now, if I hadn't removed those extra numbers for the Enermax, it would have probably been the worst one on the list. But it's not. So, did you get that one right? And here we have the pressure differential. The Sama, again, was the worst at 53, but the Vetroo was at 53.5, so essentially the same. The MantisMan was at 54. The Enermax was at 68.5, just barely being beaten out, surprising to me, by the Frostwind. Yeah, I didn't expect that at all. I don't think that the Frostwind is particularly impressive, so the fact that it got that was like a what kind of a moment, you know? So, did you guess correctly? It doesn't matter if you got it right or wrong. It's a learning experience. And maybe you feel like, oh, I should change my answer. Please don't change your answer. The point isn't that you got all the right answers. The point is that you're participating and learning, hopefully, as I am. And we can see that for sorting the whole list by RPMs, the Sama and the Vetroo and the MantisMan are all in the first quartile, the lowest quartile, the worst quartile, if you want to put it that way. and you can see the fans that are in that same vicinity. Remember, RPMs are not actually terribly important because they do a poor job of showing us how a fan will perform, although there is a strong correlation. Oh, shoot, I forgot to show it on the screen, sorry. There you go. So there is a strong correlation when you get up into the really high RPMs and airflow and static pressure, but still there are limitations that are imposed by designs for the blade, the frame, the hub size, the bearings, and so on. And there are also improvements that happen because of those same things. So you can see the Sama, Vetroo, and MantisMan are in the first quartile, making them not particularly impressive, but definitely beating out the Kingwin, Nexus, FSB, Silverstone, Sama, and some other ones at the top of the list there. And then we can see that the Enermax and Frostwind ended up in the third quartile with the best fans down here at the bottom. Let me just scroll back up there. So they did okay, but not like super amazing in terms of speed. But again, that's not that important. Let's go ahead and take a look at the pressure differential. And we can see again that the Lamptron is the worst for pressure differential at only 20. And then the Sama is, I believe the Sama is actually in the second quartile. Let's just zoom out here so we can get a good feel for that. So yeah, the Sama is in the second quartile as, and also the Vetroo and the MantisMan are in the second quartile. You can see a bunch of fans that they beat out, or beat up if you want to say that way, and many more that beat them. Sorry about that getting all screwed up there. Zooming in and out does that. And then the Enermax and the Frostwind, neck and neck, down in the fourth quartile. So they actually did remarkably well, but again, pressure differential is an experimental thing that I'm doing, and it isn't something that you can say is attributed to just RPMs or just airflow or just static pressure. It is based on multiple factors. So let's look at the airflow. And here we can see the Sama and MantisMan are solidly within the confines of the first quartile. And the Vetroo, I think, is still in the first quartile, although it's pretty close to the border there. The Frostwind is in the second quartile. And the Enermax is also in the second quartile. And finally, let's see the whole thing so that you can maybe make some observations about the relationships between the RPMs, the airflow, and the pressure differential. I'm just going to go slowly through this so you can take a look. And you'll notice there are fans that are stronger at the top of the list in terms of RPMs, and there are other fans that are stronger in terms of pressure differential at the top. There isn't any strong correlation between these three things. And that is, again, because there are lots of other factors. And there we go. So, I hope that this has helped you if you're looking for fans that you want to get. And maybe you learned something today, or maybe you're trying to develop your own kind of theory about why the results are the way they are. And if you have a theory, when you get it to the point where you feel comfortable sharing it, I would love to hear what you have to say about it. Or maybe you already know why it is the way it is. I mean, I have pointed out other factors that are involved, but maybe you can give a solid explanation. I can't at this point. Maybe someday, but maybe not also. So, thanks for watching and have a great day.
I need to ask for your help. Things have been challenging whose life hasn't been challenging lately. So if you can please help me out by liking, subscribing, sharing, commenting, and turning on notifications, that would be really, really super. Also, if you'd like to help me financially and you can't afford to, you can do a super thanks on my Glenn's Fast Reviews channel, or you can become a member there. Or if you prefer, you can go to patreon.com/GLENNMII and become a member there instead. Also, I'd like to give a shout out to Bleeping Computer for their support of my channel. If you need resources for computers, for getting rid of malware and learning about cybersecurity and stuff, Bleeping Computer, BLEEPING computer.com is a great resource. Thanks so much for watching and have a great day.